All right, super awesome math students. Thanks for checking out the video. We're going to make a key here for the assessment you guys took today. I know some of you are thinking, hey, I think I probably need some more practice, or I'm curious to know how we did those problems, so you can come back and maybe find some more success next week. I will tell you, these are tough. It's a tough concept. Students, it's kind of one of those you're going to struggle, and I think we can get you there. You know what? I really think you're going to make it, but you just have to keep working at it and making mistakes and thinking about your mistakes and then practicing some more. So here we go. This is hopefully going to help you out. So the first one, you're asked to subtract one fraction from another. So when I see subtraction, I go, oh, I have to have a common denominator. So before I worry about getting any common denominators, I'm going to look at each denominator in factored form. So if I factor the denominator of the first fraction, it puts me there. And here's the second one. What's nice about factored form, when you get denominators in factored form, is I think it makes it easier to see, what's missing or how you can combine things. All right. So when I look at this, I go, well, the common denominator should be, 2x plus 4. Well, that's fine. This guy here, kind of is what it is, but you can change how it looks. And one way to change how something looks is to multiply it by 1. So I'll do that. 2 divided by 2 it's 1. So if you multiply what we have boxed in blue by what you have in black, you just multiply top times top and bottom times bottom. So that gives you, so x minus 3 times 2 is 2x minus 6 over 2x plus 4. Okay. So we'll catch up now. 5 over 2x plus 4. Okay. So now we've got a common denominator. We can subtract those fractions. So the new denominator is 2 times x plus 4. And we're going to have, let's see, we have subtraction. Okay, so subtraction. And I'll have one thing minus another. I like to put parentheses in because you're less likely to make a mistake at the next step. Okay, so you got 5 in here, and you got 2x minus 6 in here. You'll notice with these parentheses here, they tell you to distribute that minus in. So you get 5 minus 2x plus 6 all over 2 times x plus 4. That's what? A minus 2x plus 11 over, let's multiply the bottom out. Well, okay, 2 times x plus 4. Does anything cancel out? No. The entire bottom equation, you'll notice the denominator is being multiplied by 2. And you'll say, oh, there's a 2 right there. Well, yes, there is. But that 2 isn't being multiplied by the entire numerator. It's just part of the x, right? That's negative 2x. So we can't cancel anything out. So I like to say if you can't cancel anything out, like there's obviously not a 2 sitting in the numerator, like 2 times the numerator, or an x plus 4. So I want you to multiply that denominator together and put it in standard form. So you got negative 2x plus 11 over 2x plus 8. Okay, that's your final answer. And you'll say, oh, do the two x's cancel? No, they don't cancel. Okay, because you're only going to cancel if you have the entire top and bottom multiplied by the same things. Okay, so you'll say, well, you can't write, the top isn't negative 2 times x plus 11. Okay, it's negative 2x then plus 11. And it's kind of similar to, like if you had, I don't know, let's say like 3 plus 5 over 3 minus 2. Well, okay, the answer, 3, that's 8 over 1. Right? Well, what happens if you tried to cancel these 3's out? You'd have negative 5 halves. Well, that's not right. Okay. So the answer to number 1 is is this guy right here. Now, did we ever cancel anything out? No. We just put fractions together. Nothing ever got canceled out, so we don't have to say, list any extraneous or excluded values. So, we're moving on to number 2. Okay, number 2 is a little different because you're multiplying two fractions together. You're not adding. So we don't actually, we don't have to get a common denominator in number 2. So I gotta move this guy over. Cut this. So bear with me here. So, okay, let's select all this. Alright, select all. Okay. I like to minimize this so I can keep it for our answer key. Okay, so number 2, you're just multiplying fractions together. When you multiply fractions, you multiply straight across. Anytime I get a chance to factor, the numerator or denominator in these, I'm going to do so. It's kind of like if I told you to multiply, let's say I had 4/3 times 12 over 10. Well, you could go 4 times 12 and 3 times 10. You could do that. What I would actually do beforehand is I'd strip each number down to its prime factors. So 4 is 2 times 2. The 3 on the bottom is just 3. 12 is 6 times 2, and 6 is 3 times 2. So 12 is 3 times 2 times 2. And the bottom is 5 times 2. The reason I like to do that is I can save myself some work, right? I'm looking at this fraction here, and I notice I've got a 2, the entire bottom is multiplied by 2, and the entire top is multiplied by 2. So I can cancel those out. Then when I put those two fractions together, I multiply top by top and bottom by bottom. Okay, well on the top you're going to have 2 times 2 times 3 times 2. And on the bottom you'll have 3 times 5. Well, everything is already sitting in factored form, so you can get rid of these 3's. So your answer would be 2 times 2, so 8/5. So that's my logic in wanting to take everything to factored form before I'm multiplying it together, because I can get some things to cancel out both before and after. So obviously m minus 3 is factored already. M plus 2 is. Let's see, this guy here. Let's replace that guy with its factored version. So let's see, m. Can you factor that? Oh, I covered it up there. Okay, so this number's a 1. So what multiplies to negative 10 and adds to negative 3? Oh, that would be negative 5 and 2. So that guy's going to factor there to m minus 5, m plus 2. And then the denominator, you'd say, well, this number's a 1, so we get to just do the shortcut. What multiplies to 18 and adds to negative 9? Let's see, negative 6, negative 3. So m minus 6, m minus 6, and m minus 3. Okay. So we've got two fractions to multiply together. We'll go top, top, bottom, bottom. Okay, so top, top, bottom, bottom. So you'll multiply those together, and is there anything in the top that you can cancel with anything in the bottom? You say, yes, I can take the original and rewrite it. Instead of the green over the blue, I can take this guy and cancel them, and this guy and this guy, which leaves me with m minus 5 over m minus 6. And I'd say, well, is that equivalent to what you started with? And you should say, well, I started with the green stuff on top and the blue stuff on bottom. And you'll notice with where I started, m was not going to be able to be 3 or -2 or 6. Okay. In the original expression, green over blue, I put it in factored form, green over blue, you were not going to be able to, let's say, plug, like if it was a function, you weren't going to be able to plug 3 in, 6 or -2 because they produce divide by 0 errors. Now in your new one, you still can't plug in 6. But you need to keep track of what you couldn't plug in since the very beginning, right? So we have to say, hey, by the way, also m cannot equal 3. M cannot equal -2. Okay. So, and I'll say kind of one more thing about why I stress this, okay? Why you need to write those exclusions. If you put that into the y equals on your calculator, and you put that into the y equals on your calculator, they wouldn't be identical. Okay? They wouldn't. They'd almost be identical if you looked at their table of values, like xy, xy. They would look so close, okay? The only difference would be for this first one here, when you got to, let's see, what all did we cancel out? M minus 6. When you got to -2 and when you got to 3, your calculator would say error. If you just do this guy, if you graph this guy, put it in your y equals and look at the table, when you do -2 and 3, it would tell you a number. Let's see, -2 minus 5, -7 over -8. So it would tell you 7/8, and it would tell you some number when you plug 3 in. 3 would be -2 over -3, so 2/3. Well, these guys can't possibly be the same if they don't produce the same tables, right? Correct. So the only way to say, hey, these two things are equivalent is to say, hey, these two guys are equivalent as long as m doesn't equal 3 and m doesn't equal -2. Okay? If you don't consider those two, they're equivalent. Well, you say, well, what about 6? Okay, well, if you plug 6 into this guy or 6 into this guy, you're going to get error. Okay? So they have that in common. We don't need to specify that. Okay, next problem. This is just to simplify. I think you can, factoring is your friend when you simplify. You'll notice you have quadratics here. So if that's split the middle term, so it's -8. What multiplies to -8 and adds to -7? Oh, that would be what multiplies to -8 adds to -7. So -8 and +1. So you split the middle term on top. You can factor out what 2x. And then you'll have another x minus 4 with a 1. We can do the same thing on the bottom. That's 24. What multiplies to 24 adds to -14. So multiplies to 24 adds to -14 would be -12, -2. So 3x squared minus 12x minus 2x plus 8. Okay, you can take out a 3x, and you get x minus 4 plus x minus 4. That would be what, a -2. Okay, so back to the numerator. So you got 2x plus 1 times x minus 4, and the denominator would be 3x minus 2 over x minus 4. I gotta plug this into the charger real quick. Okay, so we've factored the numerator and we have factored the denominator. We're looking for things to cancel. As it sits right now, this guy in blue is totally equivalent to this guy in blue. Okay, we're going to do a little canceling out. Okay, so I'm going to drop the x minus 4s. So that leaves us 2x plus 1 over 3x minus 2, so long as x doesn't equal 4. So this guy, oh come on computer, this guy is equivalent to this guy as long as x doesn't equal 4. Alright, moving on. Oh, my computer's acting like it's not happy, but come on computer. Okay, solve each equation, check for extraneous solutions. We'll touch on that check for extraneous solutions at the end, but I don't need you to worry about it right now. Kind of as we talked in class, just get it so both sides have the same denominator. Okay, so you should compare all the denominators and say, if I were going to make those all match, I'd want them all to be 2r squared. Okay, so we have the ability to multiply by 1, which, without changing something's value. So you should see 3 fractions sitting there in number 4. I hope. Okay, 3 fractions sitting there. I'm going to take the first fraction, which is 1 over r, and I'm going to multiply it by, let's see, how do I make r 2r squared? Well, I multiply r by 2r. So I got to do that to top and bottom. Okay, equals r plus 2 over r squared. Well, how do I make r squared 2r squared? Well, I multiply it by 2. 2 on the bottom, 2 on the top, minus blank 2r squared. So that's r plus 6. Cool. Okay, so you combine the fractions on the right hand side. So this multiplies. So that's 2r plus 4 over 2r squared minus r plus 6 over 2r squared. The common denominator is 2r squared. You have subtraction. Make sure you bring those parentheses. So you distribute your subtraction, and you're going to get, let's see, what do we got? 2r take away, so you get r minus 4 minus 6, 2 over 2r squared. And the left-hand side was 2r over 2r squared. So, this isn't meant to be real technical. You have two quantities, okay? Left and the right. Okay? The blue and the green. They're the same, right? They're separated by an equal sign. We want them to be the same. Well, if those two quantities are equal and they're both being divided by the same amount, it should make sense that the tops have to be the same. So 2r needs to be equal to r minus 2 if we're going to be able to make these, the blue equal the green. So, whoa. Close this guy. Come on, computer. 2r equals, r minus 2. So you solve that for r, so you'll minus the r over, and you get r equals negative 2. Now what do I mean by extraneous solutions, and how can you check for extraneous solutions? Well, one way to do it is, sometimes through some of the algebra you do, you kind of, these goofy things will happen, and we'll talk more in class, but your final check can be take r equals negative 2, and you just check your answer, okay? So you come back and plug it into your original equation. So you'll say, okay, self, let's see if I'm right. 1 over r. Okay, 1 over negative 2 equals negative 2 plus 2 over negative 2 squared minus negative 2 plus 6 over 2 times negative 2 squared. Okay, that's negative 1/2 equals 0 over 4 minus 4 divided by, okay, that's 4 to 8. So negative 1/2 equals, okay, that's 0 minus 1/2. Does negative 1/2 equal negative 1/2? Yes. That's how you would check an extraneous solution. You just get your answer, plug it back in, make sure it works. Okay, so moving on to 5. Factoring is my friend. I'm going to take this 24, and that's actually, let's see, leading coefficients of 1. So what multiplies to negative 15 adds to 2? That will be x plus 5, x minus 3. See, that's useful in getting your, thinking about what your common denominator is going to be. So if you compare all the denominators, the common one is going to be x minus 5. We're looking for x minus 5, x minus 3. So this guy's missing. Or sorry, it was x plus 5. This guy's missing an x plus 5 over x plus 5. And then this guy's missing an x minus 3. And on the bottom also an x minus 3. So you got subtraction here. I'm just going to work on the left-hand side. So saying you have your subtraction. So you've got, you'll have blank minus blank all over x plus 5, x minus 3. And that's going to equal 24 over x plus 5, x minus 3. Okay. And then the next step will obviously be, well, if the bottoms are equal, so must be the tops, and you set them equal. So x times x plus 5 is x squared plus 5x. 7 times x minus 3 is 7x minus 21. Oh, come on, computer. Minus 21. So this is why the parentheses are important, right? So you're going to distribute that in. You got x squared plus 5x, take away 7x plus 21 all over x plus 5, x minus 3. And that equals 24 over x plus 5, x minus 3. Okay, so let's set the tops equal now. If they're equal, if we're looking for them to be equal, and the bottoms are the same, well, the tops have to be. So you're trying to solve the equation. Now that blue piece equals that blue piece. Right? So we'll get ourselves a little space. So we want to solve this guy. We got the little, so x squared minus 2x plus 21 equals 24. Okay, move this over. Solving a quadratic, you want to get one side equal to 0. X squared minus 2x. So you subtract the 24. So 21 minus 24 is negative 3. I've got a quadratic equation. When I solve it, do the quadratic formula or factor it if it's possible. This guy is factorable. What multiplies to negative 3 adds to negative 2. Negative 3 would be negative 3 and 1. So x minus 3, x plus 1. So your solutions would be x equals 3, x equals negative 1. In your last step, you'd go back and you'd plug those into your original. So what do we say? X equals 3, x equals negative 1. X equals 3, x equals negative 1. So we'll try the x equals 3. So 3 divided by 3 minus 7 over 3 plus 5 is 8 equals 24 over, let's see, 9 plus 6 is 15 over 0. Okay, so that's, you're telling me that 3 over 0 minus 7/8 equals 24 over 0. No way, you can't divide by 0. 3 divided by 0 is undefined. So I can't verify that undefined take away 7/8 is equal to undefined. So 3 isn't one of your solutions. Okay, it is not one of your solutions. So you'd cross it off the list. You'd say it doesn't work. Undefined minus 7/8 isn't, undefined. There, 24 over 0. So if you plug negative 1 in, you're okay. You'll notice that works. So that's your solution to 5. Okay, 6, simplify. Oh, you got a quartic up top. You're going to want to factor that. We don't have a super slick method for factoring quartics. The only way this guy is going to simplify is if there's an x minus 1 factor in the numerator. Well, how would I determine, I'm going to cross out the squared here and I'll just list x minus 1 twice. How do I determine if x minus 1 is in the numerator? Through long division. Okay, x minus 1 into 3x to the 4th minus 16x cubed plus 31x squared minus 26x plus 8. So we'll not only figure out if it goes into it, we'll figure out what's left. So this would be 3x cubed, 3x to the 4th minus 3x cubed, and you're going to subtract. So negative 16 take away negative 3 is negative 13x cubed plus 31x squared minus 26x plus 8. So x, this guy here, into negative 13 x cubed would be a minus 13x squared. So plus 13x squared. This minus times a minus, gave me a plus here. Okay, so I gotta subtract that. So 31x squared take away 13x squared is 18x squared. Okay, x into 18x squared would be plus 18x. 18x squared minus 18x. Okay, subtract. Minus, so I'm subtracting a negative, so it's like adding a positive. So negative 26 and positive 18 is negative 8x. And so this would be a minus 8. And the remainder would be 0. Okay, so it turns out x minus 1 does go in there. And you'd say, well, so that means I can cancel out one of the x minus 1s. I can rewrite the numerator as x minus 1 times, let's get rid of that stuff, x minus 1 times the quotient, which is kind of cool. Okay. So you're going to be able to cancel out one of the x minus 1s. Well, what if the other x minus 1 also goes in? Like, oh, that's a pain. So now I got to try to divide just to see if it simplifies anymore. So if you think, okay, these guys are going to go away. Okay, those guys will go away. But how do we know this x minus 1 doesn't go into the numerator? So we're trying long division again. Okay, 3x cubed minus 13x squared plus 18x minus 8. Alright, 3x squared, 3x cubed minus 3x squared. Okay, subtracting a negative is like adding a positive, so negative 10x squared plus 18x minus 8x into negative 10x, so negative 10x squared. So negative 10x times x is negative 10x squared. So a negative times a negative is a positive 10x. Subtract 18, take away 10 is 8, so 8x minus 8. X times a plus 8 will be 8x, and then minus 8. Remainder 0. Oh, it does go in twice. So this equals x minus 1 times 3x squared minus 10x plus 8 over x minus 1. Okay. So those x minus 1s are going to cancel. And remember, as you cancel, like, can x be 1? No. It couldn't be 1 before you canceled, so it can't be 1 after you cancel. So your answer is this guy with the condition, hey, x cannot equal 1. So you actually divide it out. You're able to cancel out the entire x minus 1 squared in the denominator. You could have done long division once if you would have just expanded out x minus 1 squared. So it would have been x squared minus 2x plus 1. But okay, I think we have 2 to go. 1 to go. Okay, it's almost time to start the weekend. We're almost there. Oh, okay. So I am going to be brave, and I'm going to see if that factors. So 13 is a prime number, so I can't factor anything out. And this might not be worth it, but let's try. Okay, 13 times 54. Oh, this is going to be ugly. 54, I don't have my calculator in front of me. 13, 12, 15, 16, 4, 5, 600, nope. I should start from right. 2, 0, 702. So, oh no. What are the factors of 702 that add to 123? Oh, okay. Let's see. 702 is 2 times 351. Well, those aren't going to get me to 123. Okay, 351. 351 is divisible by 3 because if you add the digits, you get 3. So what is it? 351 divided by 3. 1 times 3 is 3. So we got 51. 3 times, I don't know, 3 times 15 is 45. So 15 threes is 45. 16 threes would be 48. Oh, why am I doing that? 3 into 5 goes once. Okay. Okay, 3, 2, 1, right? Okay, 7. And I would have been fine too, right? 17 threes is 51. So 117. Oh boy. Okay, 3 and 117. Well, you might be thinking, okay, this is not helping. But it is, okay? We just figured out what multiplies as 702. Did you know that it was 2 times 3 times 117? Or 6 times 117. And coincidentally, if you add 6 and 117, you get 123. So we've split the middle term. So when we factor this guy, okay, we're going to go 13x squared plus 3x plus 117x plus 54. So all you can take out is an x. So 13x plus 3. There's going to be another 13x plus 3. Okay, so what did we take out? What times 3 is 54? Let's see. Well, 20 times 3 is 60. Well, let's just do this. 54. It's Friday. My brain's not working. Divided by 3. 1 times 3 is 3. 24, so 18. I factored it. I don't even know if it's going to help. X plus 18. 13x plus 3. Oh boy. Alright, so you got 5x squared over x plus 5 minus x plus 18. 13x plus 3 over x plus 9, x plus 5. Now the only reason I factored the numerator is in hopes that maybe the x plus 9 would cancel out. But as I look at it, as long as I did this right, as I look at it, you can't get anything down here to cancel out anything up there. So what I'm trying to say is there was no advantage to factoring that numerator yet. Alright, so if you're going to subtract them, get a common denominator. This guy over here is missing an x plus 9. X plus 9. So you'll have a common denominator of x plus 5, x plus 9. When you multiply 5x squared in here, you get 5x cubed plus 45x squared minus, well, there's no sense in writing that in factored form because I'm going to have to multiply it to combine like terms. So 13x squared plus 123x plus 54. So I'll distribute the minus in. I'll gather my like terms. We're getting there. Persevere, right? You can do it. Okay, so 5x cubes plus 45x squared minus 13x squared minus 123x minus 54, all divided by this stuff. Okay. Gotta gather like terms in the numerator. I still have 5x cubes. I have how many x squareds? 45 take away 13. 32. Plus 32x squareds minus 123x minus 54. All over this. Now you'll say, well, yay, maybe I'm done. Well, the only thing you've done is you've combined the two fractions and you got a common denominator. But what's to say that now fraction you're sitting with doesn't have anything that cancels? Oh my gosh, I have a cubic in the numerator. How do I factor cubics? Well, we don't have a select method, but maybe x plus 5 goes into it, or maybe x plus 9 goes into it. How do I know which one to try first? Well, you could, one thing, if x plus 5 goes into that, that means that x plus 5 is a factor of it. And if x plus 5 is a factor of the numerator, plugging negative 5 into the numerator would produce 0. So, at the pre-calc level, if you were going to check and see if x plus 5 was a factor, the easiest way to do it, most efficient, wouldn't probably be with long division. It would just be substituting negative 5 in. Now, I don't have a calculator sitting by me, and I'm not going to go get one. So, I'm going to try the x plus 9. Just a hunch, okay? So, I'm going to try to divide in x plus 9 in, I hope I don't regret this, 5x cubed plus 32x squared minus 123x minus 54. So 5x squared, 5x cubed plus 45x squared. Okay, remember while you're doing this and you're going, this is crazy, this is ridiculous, I want to go do something fun. It is Friday at 3:40 almost, and I'm right in it with you. Okay, I'm helping you finish it. We can do this. 32 take away 45, negative 13. Okay, x into negative 13x squared. So it'll be a minus 13x. 13 times 9. Okay, well, 13 times 9. Let's see. 10 times 9 would be 90. 3 more 9s. Well, 3 9s is 27. So 90 and 27 is like 117. Okay. So minus 117x. Mental math. Okay, minusing a negative is like adding a positive. So negative 123 and positive 117 is negative 6. Oh, I think we picked the right one. Okay, so minus 6 minus 6x minus 54. So we do get a remainder of 0. Yes, x plus 9 goes into it. So we can rewrite this guy here as x plus 9 times this guy. And then the x plus 9s will drop. Okay, so it's going to be a little messy, but I'm going to go, hey, that guy cancels that guy. So we're looking at 5x squared minus 13x minus 6 over x plus 5, so long as x doesn't equal negative 9. Now, we might not be done. You got a quadratic there. You got to see if it factors. Okay. That multiplies to negative 30. Are there factors of negative 30 that add to negative 13? Oh boy. Yes. Negative 15 and 2. So, you got to factor that quadratic up there. Okay, split the middle term. We can do this. Okay, we're going to factor that quadratic. So, this is 5x squared minus 15x plus 2x minus 6. So, I take a 5x out. So, x minus 3. I'll have another x minus 3 if I take a 2 out. So that's 5x plus 2 over times x minus 3. That'll be all over x plus 5. Now, did I need to factor it? Well, I kind of needed to factor it to check because I hadn't yet verified that x plus 5 didn't go into the numerator. But now that you've got it factored, x plus 5 is not up here. Okay, it's not one of the factors. And there's nothing you can take out of one of those factors to make it x plus 5. So what's your final answer? Your final answer, assuming Mr. Lund didn't make any silly mistakes, is in green right there. Okay. So you guys are awesome. Thanks for putting in the hard work. We're going to come back next week. You're going to be a little better, or a lot better. And yeah. So thank you. Good job. And I will see you on Monday.